All right, let's dive right into this explainer. For more than half a century, the moon has just been sitting quietly in our night sky, mostly untouched. But right now, an entirely new space race is heating up. Multiple nations are literally sprinting to establish a permanent presence up there. And the stakes, they are infinitely higher than they were during the Cold War. But to understand exactly why everyone is suddenly rushing back, we really need to look at how the original race was won and why we just abruptly stopped going.
So let's start with the triumphant peak of the 1969 US-Soviet space race. When Neil Armstrong took that famous step, it was the ultimate knockout blow by the United States, pretty much ending a decades-long competition with the Soviet Union. But here's the thing. That victory was largely fueled by brilliant scientific minds acquired right after World War II. Crucially, the U.S. managed to recruit Dr. Wernher von Braun, the mastermind behind the V-2 rocket, along with over 1,600 other German scientists through Operation Paperclip. They got to them before the Soviets did, and von Braun was absolutely the decisive link that pushed American rocket technology into overdrive.
Which brings us to this massive historical puzzle. After all that incredible momentum, both superpowers just completely slashed their space budgets. Following Apollo 11, the U.S. abruptly cut NASA's funding from a peak of over 4% of the federal budget in 1966 down to just 2% by 1970. And lately, it's hovered right around 0.5%. After the final manned mission wrapped up in 1972, we entirely abandoned sending humans to the moon for over 5 decades. So what actually caused this massive, sudden absence?
Let's get into Section 1, the 50-year gap, technology and cost.
To solve this mystery, you just have to look at the staggering scale of technological advancement over the last half-century. Look at this comparison. The computer that guided Apollo 11 to the lunar surface weighed 30 kilograms and had a microscopic 4 kilobytes of RAM. Compare that to the very first iPhone from 2007, weighing just 113 grams, but packing 128 megabytes of RAM. That early iPhone had 32,000 times more memory than the entire Apollo spacecraft. Today's computers can literally drive cars. This tech explosion proved that unmanned probes could be incredibly capable, completely removing the massive risk of sending human crews.
And avoiding that human risk also avoided astronomical costs. The original Apollo missions were an unbearable financial burden, costing the modern equivalent of roughly $250 billion. That price tag was justified during the Cold War because the race was heavily driven by political goals, not scientific ones. Actually, out of the 12 NASA astronauts who walked on the moon back then, only one was an actual scientist. Once the political victory was secured, there was just no reason to keep funding such wildly expensive human missions.
Just compare that staggering $250 billion to modern equivalents. India's 2023 Chandrayaan-3 unmanned moon landing cost a mere $75 million. That is a fraction of the Apollo budget. It perfectly shows why automated missions became the absolute go-to method for space agencies. Why send humans when a robot can do the exact same job for a fraction of the price?
Plus, the early moon was basically viewed as a useless, barren desert. Think of it like Christopher Columbus finding a new land. If explorers arrived and found absolutely no valuable resources or strategic advantages, they wouldn't build a colony. They just move on. And that is exactly how politicians viewed the early lunar samples brought back in the 60s and 70s. It just seemed like a giant floating wasteland.
Which leads us to Section 2, the multi-trillion-dollar discoveries.
The entire paradigm shifted thanks to samples brought back by Apollo 17 in 1972. That mission included Harrison Schmitt. Remember that one scientist I mentioned? Well, as a trained geologist, he handpicked highly valuable rock samples. After decades of advanced analysis on those rocks, scientists realized the moon's surface is practically overflowing with easily accessible raw materials, like silicon, aluminum, and titanium. Unlike down here on Earth, where we have to dig deep mines to find these mixed with a bunch of impurities, on the moon, they're just sitting right on the surface. Extraction would be incredibly straightforward.
But here is the real kicker. Helium-3. It's an extremely rare isotope here on Earth, but according to NASA estimates, there are over 1 million tons of helium-3 up on the moon. This stuff is the holy grail for nuclear fusion and rocket fuel. By simply heating moon rocks to about 600 or 700 degrees Celsius, we could easily extract it. The energy potential here is so vast that mining it could supply enough energy to power the entire Earth for 10,000 years. Yeah, 10,000 years.
And the ultimate game changer arrived a little later in 2009. NASA's uncrewed LC-CROSS and LRO probes confirmed what scientists had suspected for decades. There is water on the moon. Now, we are talking liquid oceans, but rather frozen water molecules trapped beneath the surface, specifically hidden inside the permanently shadowed craters of the lunar South Pole. This discovery gave nations exactly what they needed, a local source of hydration and potential oxygen to finally justify setting up a permanent human presence.
All right, let's move on to Section 3. Enter the modern space race.
Today, 5 nations have successfully landed on the moon: the Soviet Union, the US, China, India, and Japan. While the US is historically the #1 seed, China has built some rapid, compounding momentum right behind them. Despite a late start, sending their first astronaut to space in 2003, China quickly launched the U-2 rover in 2013. Then, in 2019, they became the first nation in history to land a rover on the dark side of the moon. And in 2020, they successfully retrieved lunar soil samples, the first time any nation had done that since 1976. Now, China's sights are set on landing humans on the surface before 2030.
Meanwhile, the United States, despite currently leading the pack after the successful uncrewed Artemis 1 mission in 2022, has definitely faced some recent hurdles. NASA officially announced delays for their upcoming manned missions. Artemis 2, a crewed flyby, got pushed to late 2025. And Artemis 3, the monumental mission aiming to finally drop astronauts onto that resource-rich lunar South Pole, has been pushed back to late 2026.
And that brings us to Section 4, the battle for lunar territory.
As the battle lines extend off the lunar surface and into the zone between Earth and the Moon, which is known as cislunar space, understanding this next concept is absolutely essential. I'm talking about Lagrange points. There are 5 of these zones, labeled L1 through L5. In these specific pockets of space, the gravitational pull of the Earth and the Moon perfectly cancel each other out. That means they are the ultimate strategic real estate. A spacecraft can effectively park there indefinitely, completely stationary, without having to burn any precious fuel.
Out of those 5, point L2 is arguably the most critical. Why? Because it sits directly behind the moon, giving us an uninterrupted communication bridge to the lunar dark side, an area completely blocked from Earth's radio signals. China recognized this massive strategic value early on. They launched their Queqiao relay satellites to point L2 in 2018 and an upgraded version in 2024. This early infrastructure directly paves the way for their upcoming Cheng missions. And for sure, the US is eyeing these exact same points, aiming to master all 5 Lagrange zones.
Back here on Earth, a massive diplomatic division is unfolding to support all these ambitions. The U.S. is building a huge coalition through the Artemis Accords, an ambitious framework for peaceful lunar exploration. They've gathered over 30 allied nations, including the UK, Japan, Australia, the UAE, and Nigeria. In direct opposition, China has declined to join this alliance. Instead, they're partnering with Russia to construct their own dedicated base, the International Lunar Research Station, right at the South Pole. So why is this diplomatic split so critical? Well, because this race isn't just about the moon anymore. The moon's surface, with its lower gravity and abundant rocket fuel resources, like helium-3, is just a staging ground. It's the ultimate launching pad for deeper space exploration to Mars, Saturn, and way beyond. Whichever coalition establishes dominance at the moon's South Pole first will effectively dictate the rules of engagement and control the logistics for the rest of the solar system.
As we wrap up this explainer on the source material, I want to leave you with a final high-stakes question to consider. Both the US and China are highly likely to succeed in their lunar goals. This means they will inevitably end up trying to claim the exact same highly lucrative craters. Given the intense political tensions between these nations back on Earth, what happens when rival superpowers suddenly become next-door neighbors in the freezing, lawless expanse of the lunar South Pole? It's an incredibly fascinating and maybe a little chilling prospect as we watch this new era of human exploration unfold.